I'd like to then introduce our next speaker, Simone Severini, who's Director for Quantum Computing at Amazon Web Services. Simone is responsible for designing and delivering the strategy of Amazon Web Services in quantum technologies. He's also a professor of physics of information at University College London, where he contributed to starting the UCL Quantum Science and Technology Institute and several industrial projects. He's held advisory roles in the public sector, private equity funds, and also was involved in some of the world's first quantum technology startups, Cambridge Quantum Computing, now part of Continuum, and Phasecraft. Welcome.
So, thank you. Thank you very much. So I need to stay here, right? Because if I move there, then the microphone won't work. So I'll stay here. So, title of my talk, Working Backwards in Quantum Computing, Some Lessons Learned. What does it mean? This term, working backwards, is very much an Amazon term. So it means when you try to build something, first talk to customers and try to understand if there's a problem that is important to solve. And you ask some questions. First question is, who's the customer? Second question, what is the customer problem? And so on. Okay, this is something that when I joined AWS about 4 years ago, I had to do. So I had to talk to customers for 6-8 months to try to understand what made sense for a company like AWS to do in quantum computing. And the very first question that I would like to consider in this talk is why quantum computing at AWS. And there are two reasons, really. So the first reason is learning, and the second reason is hopefully help accelerating innovation in this space. Learning together with our customers. There is a term that people use fairly frequently out there, which is quantum readiness, being quantum ready. For AWS to be quantum ready is really to try to understand how to integrate quantum hardware in a complex IT infrastructure, and at this stage, it's valuable to start really trying to figure this out, because it's not something you learn overnight, it may take years. So, this is a slide with a lot of logos. AWS works with over 1 million active customers, global portfolio of customers in 190 countries. Think about Airbnb, think about Netflix, Pfizer, Salesforce. So I spoke with a number of customers, and it was evident that one thing that people kept saying is we want to understand where quantum computing is. We are very confused. Is quantum computing going to happen tomorrow? Is it going to happen in 10 years, during our lifetime? And myself, in trying to answer this question, I understood that one thing that people really wanted is some kind of clarity in this space. Okay. There are HPC customers. Here I have 3 examples. Commonwealth Fusion Systems, they built fusion. Boom Supersonics, they built airplanes across the ocean, flying across the ocean, fast airplanes, and Moderna Therapeutics that came up with one of the COVID-19 vaccines. So these companies work on HPC, high-performance computing in AWS, and at some point there is a chance that companies of this type are going to be affected by quantum computers, and they ask, okay, what should we do now? Okay. Who's the customer then for quantum computing? The very first question to ask. So there are 3 types of customers from what I've learned. So the pioneers, academic researchers, people that do science, they push the boundary of the field. But then in this category, there are not just academics, there are also companies, organizations, startups that are trying to come up with ways to program quantum computers, ways to access quantum computers, to mitigate errors, and so on. And then there are the enablers. Think about Deloitte, think about Accenture, think about Capgemini. Think about these organizations that know business very well, and they have their customers that ask them to help understanding if and when quantum computers are going to be useful for them. And then pragmatists, enterprises. Companies that say, I don't care about quantum computers, I care about solving this specific problem, and I would like to know if quantum computers at some point are useful because I need to know whether I should invest or not. And here is what we are doing on the basis of these 3 type of customers. So we are doing 4 things. We have 4 initiatives. I start from the top. First initiative is called Amazon Bracket, and it's an AWS service which is generally available, meaning everyone can use it. You can access it from your mobile phone now, and you can have access to some simulators, but also access to quantum computers. Some, let me call them prototype quantum computers. Maybe some people in the room say, no, don't use the term prototypes, no, these quantum computers. Okay, let's say early quantum computers, right? So some quantum computers that people build today, and people say, look, we want to have clarity in this space. Okay, access quantum computers, see yourself where the state of the art is. So that's the reason to build this service. So second thing here on the right is called AWS Center for Quantum Computing. It's a research organization. We want to build fault-tolerant quantum computers. We believe in error correction, whether it's religion or not, so this is something to discuss. But this is a long-term investment. Think about the next 10 years, okay? So this is in partnership with Caltech. We actually built a building in the campus of Caltech, which is pretty cool because from what I know, it's probably the first building in history that has been built specifically for quantum computers. So we have to understand how the floor needs to be made and so on. Down, AWS Center for Quantum Networking, you need to connect quantum computers, lots of interesting opportunities there, security and so on. You know about this stuff better than me. I'm in the right place to talk about this topic. This is in partnership with Harvard University. We launched it a couple of months ago. And then we have a professional services organization called Amazon Quantum Solutions Lab, a consulting business that interact with customers and think about enterprises that say, okay, I want to understand what's going on in quantum computing. Can you help me? They work with them. But these are experts also in machine learning, HPC, and so on. Okay, first, let me pause for a second. Let me tell you about Bracket, the service. What kind of problems we wanted to solve with Bracket? Customers need a one-stop shop for exploring quantum computing. That's why Bracket. This is a screenshot from the service dashboard from the internet. I took it yesterday. If you are familiar with machine learning, you can use some tools that people like in machine learning, like Jupyter Notebooks, for the people in the room that know this topic. There is an SDK. And these are the machines, the quantum computers available on Bracket today. There are 5 quantum computers, and there is D-Wave that moved to AWS Marketplace recently. So there are 3 universal quantum computers, IonQ, Rigetti, Oxford Quantum Circuits, so 2 superconducting devices, 1 ion trap device, NISQI machines, right? And then there are 2 special purpose machines. One is Xanadu. You know, this is a supremacy computer that they do boson sampling, and it's interesting because it can solve some mathematical artifact faster than classical computers. And QERA, which we launched very recently. Some interesting science could be done in QERA machine, analog Hamiltonian simulation. For example, you can try to I'll tell you later, I have a slide specifically about QERA. Okay, fully managed, people talk about serverless. What does mean serverless? It means that you don't need to manage infrastructure. You know, you log in into the console and then you launch a simulator on one of these devices and you don't need to care about what is happening. So we have a bunch of simulators. In fact, you can even bring your own simulator. So if you have a favorite simulator for quantum computers, just put it up there and it's fine. So let me take up my phone because I can't determine the time. I don't see a clock in the room, so I could very easily end up to talk too much. So, okay, so what people are doing with this today? Here is an example. This is a partnership we have with the government of India, Ministry of Electronics, Information Technology. There is a grant scheme for getting credits to access these machines. It's a competitive grant scheme. So this is the first cohort of universities that accessed the grants, 17 universities. I hope that some interesting science will come out from these teams working with Bracket. And this is something that happened last week. I like it. So this is Cuberaid, startup that came out from the Duality incubator, if I'm not mistaken. Kanav is somewhere up there. He has a red jacket. You can see him. So they run an hackathon, 630 participants, 68 countries, I think last week. Very interesting, right? So we want to engage people out there. This is, I think, an excellent opportunity. They run stuff on AWS and Bracket. Okay. So when you think about AWS, We just heard a talk by Anne. You know, we want to give choices to customers. So if you think about the hardware that we have there, of course, we work with Intel extensively, AMD, and we built our own hardware, the Graviton processors family. Now, for quantum computing, it's going to be a similar situation. So now we offer quantum computers built by people out there, startups, hopefully helping them building infrastructure. But on the other side, we would like to build our own quantum computers in the fullness of time. Now, one important point that actually we heard in the previous talk is the importance of integrating quantum computers with HPC, right? Quantum computers with classical resources. And customers really start asking about this, and that's why now I put this slide here, which is a little bit overcomplicated. There are lots of logos, so don't look too much at the logos. But what I want to show with this slide is really the fact that Amazon Bracket, that corner there, is part of a complex environment of microservices. And you could really try to build things on the basis that now you use a quantum computer, but you have all sorts of other microservices that you can interact with from the same environment. And I think that this is very valuable. Very valuable, why? Because, as you will see in a second, there is a number of organizations out there that are trying to build something on top of this, and they use quantum computers almost as a detail of something much more complex that will require storage, require computer, require security, access management, and so on. Okay, now going back to the typology of customers, one type of customers are pioneers, people who do science, right? They want to explore new novel use cases. So on one side, it's very difficult to build quantum computers. As we know, on the other side, the articulating useful application is highly non-trivial. And analog Hamiltonian simulation is a novel use case. One of these machines we integrated recently, QERA, 256 qubit, Rydberg atoms. Hopefully some interesting science will come out from this machine. I hope so. But pioneers, again, scientists, need tools to get the most out of quantum processors. You need to squeeze out power from these machines. And that's why we launched very recently something which is called Amazon Bracket Pulse. So you can access really quantum computers bare metal. So not sending circuits, but you can really operate at the pulse level. And this is going back to this working backwards exercise. Customers asked us to build this. Specifically, scientists said, look, we want to access quantum computers at the lowest possible level because we want to understand, for example, error mitigation. So we launched this very recently. Now, enablers. Enablers, these organizations that help customers interact with technology. So instead, they need programming interfaces. And so what we did, going back to this idea that quantum and classical need to work together, about a year ago, we launched something which is called Hybrid Jobs, which is an orchestration layer that allows you to use a quantum computer, but then is event-based. You use a quantum computer, you measure, and it spins maybe a cluster, and you do some classical computation, and then it goes back to the quantum computer. You don't have to do it yourself. This is automatic. You could run, for example, VQEs or QAOA, these algorithms people here in this room are familiar with this topic, in a way that you don't need to care about resources or where you run and how you run classical computation. And there are the pragmatists. Pragmatists are people that really don't care about quantum computers. They care about solving specific business problems. And you see, here on this slide, there is a number of organizations that are building stuff on AWS, using Bracket, working with consulting services. And here are a few interesting examples. I start from top. QCware, startup in Palo Alto. They have a platform for doing some, for running some quantum algorithms, for finance, for chemistry. It's built entirely on AWS. And Bracket, meaning the way to access quantum computers is a detail on this, because they use a lot of other stuff, as I was saying before, a lot of other microservices. Cuberaid here, SuperTech. I put SuperTech next to Cold Quanta because, as you know, SuperTech was acquired by Cold Quanta. Very exciting, successful story here in Chicago. They work with AWS and so on. So these are companies that are building stuff using Bracket and using AWS services. this is just a quote from Asif Sinai, who is a co-founder of QEdma. He's an Israeli startup. He says, well, I use the Amazon bracket for doing A, B, and C, so it's too long to read. Duality. So Duality, as you know, is an incubator, very successful, 6 startups for each cohort, is based here in Chicago. We support Duality, and we proudly support Duality. And great success stories already that came out recently. Of course, SuperTech is one of those. Very quickly, going back to what people are doing with these quantum computers today, that at least we see, it's super early for quantum computers, right? But it's so important, I think, at this stage to articulate use cases that every opportunity is good. And something I really like is this BMW Group Quantum Computing Challenge. This was a challenge open to people out there. BMW, and by the way, there's BMW people here in the room. You can ask them directly. Elvira is sitting there. So they chosen 4 problems, very practical, very real, concrete, industrial problems, important for them. And there were 70-some missions from 16 countries to try to attack these problems with quantum computers of the future, of course, because we know where quantum computing is, right? But in the future. And this is a way to crowdsource activity around quantum computing and try to start thinking about real-world problems. We had 4 winners, 1 qubit. Actually, there is a typo there, Accenture, Pascal, and QCware. Okay, I have a couple of minutes left. We build our own quantum computers. We have an organization called AWS Center for Quantum Computing, which is based at Caltech. We interact with a bunch of universities. By the way, Lian Zhang, that is here at University of Chicago, works with us part-time as an Amazon scholar. Thanks, Lian. This is just a slide that shows a little bit the different things that people are doing there, full stack. And here are the criteria. Oscar Painter is the person that runs our hardware project. So here are his criteria. So what he would like to do, and by the way, contact him directly if you want more information on this topic. He would like so he says that for me, a practical quantum computer is something that has 100 or more qubits, first of all, that perform a universal set of gates, obviously, and run error-free for a substantial amount of time, and the clock rate should be reasonable. So what we are trying to do, this is long-term investment, is to try to satisfy Painter's criteria. Anyhow, he's the person that owns the project, and it's his responsibility to get there or not. So I hope that I can see it. We have this partnership with Harvard. We launched it last summer. Quantum networks. Here on the bottom of the page, I put a title of a paper that we published on Science. Very recent, they published, I mean, people working in the team, not myself. I'm an administrator, not scientist at this point. Exciting. I hope quantum networking is coming up very soon with things that is worth talking about. So just to close here, I have a couple of extra slides that I really like to show. And this is not philosophical, but you see, there's lots of talking about industry, right? And startups and customers. And so we shouldn't forget, in my view, and sorry if this is superfluous in front of this audience, of course I am where I am, and I can see people sitting in front here that are the first people that mentioned this, but quantum computing is a science, right? So meaning that, in my view, the very first application of quantum computers is a better understanding of nature, right? So think about a telescope. A telescope allows you to see farther. A quantum computer allows you to compute farther. In fact, to see farther, to see into this quantum realm that so far we couldn't access in the way that we can access with these devices that hopefully will give us some opportunities in technology that we can't even think about at the moment. And I like this sentence. I use this all the time these days. This is Charlie Bennett. I took this picture in China while he was explaining to me some cellular automata a few years ago. So if you think about quantum computing as a field, I think this is pretty inspiring. That's why I want to keep using this slide. So the greatest achievement of our field won't be to speed up computation, but to help people understand that this world is quantum mechanical. And so this brings us back to this perspective that we need to be patient, we need to set the right expectation, we need to work with each other. Academia is fundamental, interaction between industry and academia is fundamental, and then in the fullness of time, very interesting things will happen also in technology. So thank you.
Thank you, Simone, for this inspiring talk. We can take some questions.
Thanks for the wonderful talk. My question was, so what's AWS Marketplace, and how is it different from Bracket, and why did D-Wave move from Bracket to Marketplace?
Let me go here. So AWS Marketplace is a place where people put software, also devices. It's very big. There's lots of different things. And so right now on Marketplace, if you think about quantum computing, there is D-Wave, there is some, the term that people use these days is quantum inspired. There is some Toshiba offering, simulated bifurcation machine, which is something for solving optimization. There is something offered by Fujitsu, which is a digital annealer. And, but it's something that's much broader than the service itself. So people can reuse stuff in Marketplace together with other services and is independent of the service itself.
So why did D-Wave move from Bracket to Marketplace?
Very recently, I think. Why?
Do you know why they did it?
Sorry?
Do you know why they moved from Bracket? Like they're moving from Bracket to Marketplace? So
I think that Marketplace is, to some extent, maybe a mature environment for also offering software. And D-Wave has Ocean, which is a great piece of software for accessing the machine, so people can buy different pieces of software and put it together in Marketplace. Yeah.
Thank you.
Sure.
At the back there.
Thank you for the talk. So you talked about the painter's criteria for that's great. Like, and it helps us define the kind of qubits, the things that we are aiming at. Is there a central, like, is there a computing architecture that you have in mind for that?
Yeah, sure. They do cat qubits, and they do superconducting qubits, by the way. So superconducting devices, and there is a bunch of papers that they post out there, more or less, about there is, in fact, there is an architecture paper which was posted, if I'm not mistaken, in 2020 at some point. So yeah, there is a blog. If you go on the internet, AWS blog, Quantum, you can find information on this topic specifically. Yeah.
I'm talking like more in terms of, say, like you have networking in one corner of the US and computing in the other corner. That's great. When it comes to networking, right, so things like memories are central, things like having the right wavelengths are central. So I'm thinking more in terms of, is there a parallel to, say, the von Neumann architecture, right? Is there a block for memory? Is there a block for computing? Is there a block for storage? Things like that. Is that how you're thinking about it? I know about the cat codes paper. That's the one I think you're referring to. But
so, I'm sorry, I haven't understood exactly the question.
A high-level architecture, right? Is it going to be distributed in the sense that, is there going to be a processing block? Is there going to be a memory block? So are the capabilities distributed like that? Or because it's qubits, you're trying to reimagine the whole thing, where the memory is kind of integrated into the qubit that you're also using for compute, also using for storage?
I'm not sufficiently knowledgeable to answer this question. I'm sorry. So this is a technical thing. I think if you go on the blog or you see the papers that they publish, you can see what they have in mind, or Oscar directly. I mean, please, I can put you in touch. He can answer you directly. Yeah. So as I said, I'm an administrator these days. So
if I may interject, it's probably fair to say that the details of the architecture of the future computer remain unknown at this time.
Thank you. Thank you.
Thank you.
Let's take another question over there.
Hi. So you described the landscape as there being pioneers, enablers, and pragmatists, but I think it's definitely possible that there will be some ideas coming out of industry from the pragmatists that the scientists haven't thought about how to solve yet.
Sure.
So how can you bridge that gap?
Sure. So pragmatists, yeah. So think about organizations out there like Fidelity, JP Morgan Chase, Goldman, and BMW. These organizations, they want to solve problems, right? But then they also do science. They publish their papers, and I guess in this working backwards exercise, we will try to build what these people would ask us to build in order for them to take the most out of the machines, right? So I think fantastic. Innovation is happening across the board, and if there is some pragmatists that come up with interesting ideas and they suggest us to build something for them, super happy to do it, yeah.
So I will ask more of a philosophical question. I really enjoyed your conclusion. It was very honest. But so in this field, don't you think there is a little bit of a hype?
Oh.
Like, for example, sorry, I know that maybe I will not be very popular saying that, but I do simulations of materials and chemistry, and every paper in our field starts saying that we are going to solve all the chemistry and material science problems with quantum computers. And at the end of the day, they always show results on the typical toy system with 2 or 3 hydrogen atoms. And I don't know, are we doing a favor to ourselves, or is it bad?
So let me answer this question in 2 ways. So you are Italian, right? So I will answer to your question in Italian. Apri una porta aperta means you are opening an open door with me. So yes, of course, hype is an issue, right? I mean, it's clear, and like in every new technology, there is gap in information, and this gap is filled with noise, right? So think about self-driving cars. Think about machine learning, right? So that's what it is. I think that what we need to do, we need to set the right expectations. So when you talk to a customer, one shouldn't say to the customer, look, these quantum computers are going to cure cancer before the end of the year. No, you have to tell them, look, this is NISC, right? These are noisy devices, right? So that's, in fact, to me, a tool like Amazon Bracket is useful even in this perspective, because if you want to understand where technology is, you can go there and in principle you can figure it out yourself. And you will see that technology is super early, right? Extremely early. And I think it's a matter of setting the right expectations, and it's a matter to keep the scientific perspective, really, right? Because we shouldn't forget that, and indeed, thanks for the compliment on the last couple of slides. Quantum computing started as a science. Right, so there are some areas to some extent that start from technology directly. Think about robotics, right? So robotics, you want to solve a very practical problem. Then of course it's a science behind robotics, right? But quantum computing really, I don't want to say it's an accident, but Shor's algorithm is an accident. Right? Because, quantum computers, first of all, they seem to be machines for controlling and manipulating quantum mechanical systems. So, indeed, simulation of nature, right? So we go back to the Feynman intuition and so on. But I think it's 2 points. Set the right expectations, and second, keep very strongly the scientific perspective. Even in building a quantum computer, the story, how many bits do you have? I can have 10,000 bits, but if this is a soup of qubits, right, which is a random number generator with 10,000 qubits, what am I going to do? So that's why important to look at architecture, important to look at material science, go back to the basics, and so on. Anyhow, science and the right expectations.
Let me ask a question then. You shared a very impressive overview of these different areas where AWS is working. In my mind, there was one area missing, which is quantum sensing, which some people believe may be the first real application of quantum technologies. Any comments?
So yeah, so there is a guy in Pasadena called Alex Retzker. He's a quantum sensing guy. Every other time I go to Pasadena, he tells me, Simone, why don't we do quantum sensing? He works at AWS. So as I was saying at the beginning of the talk, everything we do, or most of the things we do, come from customer conversation. So far, I haven't seen on the side of customers sufficient questions around quantum sensing, which could be due to the fact that maybe quantum sensing has not been hyped enough, right? So in full honesty, I would keep open the possibility that at some point we start working in quantum sensing. Why not?
Okay, thank you. Other questions, please, in the middle.
Hello, thank you again for your presentation. I have a question about middleware. So you mentioned before that besides the pioneers, a lot of these customers need a certain level of abstraction away from the nitty-gritty of the quantum computer. And some of the companies that you mentioned using AWS, for example, QCware, they are trying to a certain degree to develop the middleware that will allow people to access and really understand how to use quantum computers. How does AWS see its role as a compute provider versus an interpreter or a middleware creator for those kinds of applications?
So I think we need to be very much open-minded about the middleware, right? So it's very early days even for software. I see that people use a lot of different things. Now, middleware, let me see. If you look at the software stack, there is Pulse, there is like OpenChasm. Let's say we adopted OpenChasm, by the way. Then there are these things that are a little bit farther up, like Penny Lane. Would you put Penny Lane in middleware, or it's already too high up, according to you?
I guess for me, if you're looking at a specific application,
yes,
that's a bit too far up, but that's something that I think everybody's still trying to define right now, right?
Yeah. So, look, I'm not sure exactly how to answer your question in the most intelligent way. I think we need to be open-minded and see what is emerging out there and what customers ask us to implement. So I don't have a precise opinion on this, yeah.
Thank you. Other questions, please?
Hi there. Thanks for the very nice talk. So I don't want to ask this question in a way that's going to be too galvanizing, but you focused on this idea of kind of engineering backwards from what customers want. Yeah. Do you think there are any cautionary tales in quantum science of companies or organizations who have not engineered from customer demands?
I don't know. So there is, do you know Graham Smith? In Boulder, right? So some time ago, he posted on Twitter something that was quite funny. He said, 80% of what is happening in industry in quantum is busy work, he wrote. So I actually called him after. We had a conversation about this. I wanted to learn more about this perspective. So I think that if we really try to understand what is important to solve now, it's easy to get trapped into this idea that technology is interesting, right? It's cool. Oh, we have this amazing idea. Let's do it. Okay. Why it's an amazing idea, right? So again, sorry, I mentioned Feynman once. Now I sound as a crackpot if I mention Feynman twice. But the first person you fool is yourself, right? Usually, yeah. And this happens in industry as well, right? So you and me, we get together, we have an idea. We have this stuff. Let's do this startup. Amazing. We have this technology. It's fantastic. Is it going to be impactful? Is it going to solve a problem that is useful to people out there? Maybe not, right? Maybe we are fooling ourselves because we are excited about technology. So I don't know. I mean, if you look at the landscape out there, you see a little bit of everything. You see people that are trying to solve some very, very specific problems that are well-known problems, right? And then, of course, there will be some organization trying to take an opportunity. You and me are experts of topic X, and we see that now there is a lot of investments out there in quantum computing. Maybe you and me, we get together and say, okay, let's try to get some money to try to push this topic X. So, I don't know, it's a very interesting topic, and it requires some thoughts. I guess that, how would you summarize or compress your question? Is everybody out there trying to solve some problem, or are people that try to come up with, I don't know, maybe there is even the need of everything, right? I'm sorry, I'm just trying to put down everything that comes to my mind. Anyhow, out of time, so see you at the coffee break. See you at the coffee break.
That's correct. Thank you, Simone and Anne, and it's now time for coffee.